Here we have a function, 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. This function has a y-intercept. They want us to find the y-intercept, an x-intercept at the points, vertical asymptotes, and horizontal asymptotes. Okay, so we have a lot of things we need to find on this problem. Let's start with the y-intercepts. How do you find a y-intercept? So number one, a y-intercept. Remember, intercept points are always found by setting the opposite letter to 0. So if I set x equal to 0, I'll find a y-intercept. Why is that? Well, look at a function, for example. So this right here is an x-intercept, because that intersects the x-axis. And this up here is a y-intercept, because it hits the y-axis, right? Notice at the y-intercept, the coordinates would be over 0, up some number. That's the x and the y. Notice the x is 0 at a y-intercept, because at a y-intercept, the point is right and left 0. The x is 0. All right, so let's take this equation then, this function. This is y out here, isn't it? Y equals 3x squared minus 4x minus 4 over 3x squared minus 13x plus 12. And let's take that 0 and put it in, put it in, put it in, put it in. So I get y is minus 4 over 12. Everything else is just gone, 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 because it's 0, right? Then reduce that. That's minus 1/3. I just divided top and bottom by 4. So y is minus 1/3. So y minus 1/3 came from x 0. So that's the point 0 minus 1/3, right? That's the x and the y, and that's what they got down here. So that's the the y-intercept. Put that a little better. There we go. Minus 1/3. So now, step 2, let's see if we can find the y-intercept. I'm sorry, the x-intercept. So now for the x-intercept, what are we going to do? Set y equals 0, right? Because at an x-intercept, that would be the point over some number, I don't know, up 0. The x would be some number, and the y would have to be 0, wouldn't it? Because if you're at an x-intercept point, your height is 0, your y is 0. So that's important to remember. Whenever they ask us to find intercepts, you set the opposite letter to 0. So at a y-intercept, we set x to 0. At an x-intercept, we set y to 0. Okay, so I take the same equation again, y equals 3x squared minus 4x minus 4 all over 3x squared minus 13x. Oops, forgot the x there. Better get that a little better there. 13x minus 13x plus 12. Okay, and I'm going to plug in 0. I'm going to take the y0, I'm going to pop it in right there. So this becomes 0. I put it in the place of y. So there's the equation I'm trying to solve. I have a fraction equal to 0. How? So, right, you picturing that? So we have this fraction. We have this fraction right here equal to 0. It's equal to 0. How does a fraction become 0? I hope you know the answer to that question. It's important. If you have 0 in the top of a fraction, that makes it 0, doesn't it? Like 0 divided by 3 is 0, right? If you what if you have 0 on the bottom? Let me make sure you're clear. 10 divided by 2 is 5. You all know that because 2 goes into 10 5 times. So fraction means divide, just like 3 goes into 0 no times. What does it mean to have 0 on the bottom of a fraction? Again, bottom into top, right? 2 goes into 10 5 times, 3 goes into 0 0 times. So do the same thing. 4 into 0 How many times, in fact, why don't I bring it down here? How many times does, 0 into 4. How many times does 0 go into 4? Not 0, but infinite. It goes in and in and in and in and in, right? 0 can go into 4 forever, whereas 3 can't go into 0 at all. So 0 in the bottom of a fraction is infinity. 0 in the top of a fraction is just 0. So the only way for this fraction here to equal 0 is for the top to equal 0, right? Only the top can make a fraction equal to 0, right? Only 0 in the top makes the fraction equal to 0. Not 0 in the bottom. That makes it infinity. So that's very important. Let me write that down. You need to know that. When you have a fraction equal to 0, it means the top is 0. Very, very important that you know that. So fraction equal to 0 means the top equals 0. Okay, so then go back to it. So I'm just going to take that top then, right up here, bring it down. So I'm going to say the top must equal 0. Really important that you know that. For a fraction to equal 0, the top must equal 0. How did we get here? We're trying to find x-intercepts, which meant we had to plug in y0. We plugged in 0 for y, and that meant the fraction equals 0, which means the top is 0. Okay, now how do I solve that? This equal to 0. Well, you could either factor. So let me bring it over here. Well, here let's just do this. I'm just going to do the quadratic formula. So when you have it equal to an x squared equal to 0, I'm going to do the quad. So it's going to be x is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the a, this is the b, this is the c. So we have a, b, c. So x will equal negative b, negative 4 plus or minus. This is how we solve any x squared equation. You can either factor it or you can do the quadratic formula. B squared minus 4 times a times c all over 2a. So what does that equal? X will equal positive 4. Plus or minus square root of 16. Negative times positive times negative. 2 negatives makes positive. 48 all over 6. And so this is 4 plus or minus the square root of, what's that, 58, 56, 64 all over 6, which is 4 plus or minus 8, right? Because the square root of 64 is just 8. So then that means x is 4 plus 8 over 6 or 4 minus 8 over 6. So x is 12 over 6, which is just 2, or negative 4 over 6. Reduce that fraction, divide top and bottom by 2, negative 2/3. So those are the two answers for x. So both of those x values came, where'd that come from? From setting y back here, see it right here, y to 0, right? Because they're x-intercepts. To find intercept points, we set the opposite letter to 0. So to find an x-intercept, we make y 0. We plugged in 0 over here for y equal to the fraction, which means the top of the fraction is 0. And then we set it equal to 0 and solved. And so we got the two answers, 2 or negative 2/3. So that means x is 2, and that going with a y is 0, comma, or x is negative 2/3, again, going with a y 0. That's how they got those two answers there for the x-intercepts. Those are the x-intercepts. Good. Okay, so by the way, you could have also factored. Maybe I'll do that on the next one. So now, step 3, we're going to try to find the vertical asymptotes. So let me come on down here. This is a very long problem. So step 3. Whoops. So how do we find vertical asymptotes? So we have our function up here, and we want to find its vertical asymptotes. Let me yeah, let's grab it. It'd probably be good if I could just bring it down here. Let me do that real quick. Okay, so coming on down here. So there we have it, right there for us. Okay, so find the vertical asymptotes. How do you find vertical asymptotes? Well, remember, vertical asymptotes, that's a place on a graph where it goes up to positive infinity or down to negative infinity, right? So it's a vertical dotted line that guides the graph up to infinity and down to negative infinity. Well, what makes a graph go to infinity? Well, we had infinity right back here a minute ago, remember? There's infinity. When the bottom of a fraction is 0, huh? So that's going to happen. A vertical asymptote is when the denominator equals 0. So this denominator, we've got to take that denominator and set it equal to 0. That's what makes a vertical asymptote, because if the bottom of a fraction is 0, any number over 0 equals infinity, because 0, remember, a fraction means divide, bottom into top. 0 goes into any number an infinite amount of times. If that's a positive number, it's positive infinity. If that's a negative number, it's negative infinity. That's what makes graphs go up and down to positive and negative infinity, a vertical asymptote. So now I need to solve this. So this is just like the one we did before. We can do the quadratic formula. You could factor it as well. Let me show factoring this time. You could factor. You could go 3x and x, because those multiply to be 3x squared. And then you could say, okay, what's going to multiply to be 12? Well, 3 and 4. And you could put 3 here and 4 there. And let me give you a hint. You'll never have the same two numbers. Not the same numbers in the same parentheses. It's never going to work that way. Why? Because you could take a 3 out, right? If there was a plus or whatever, you could take a 3 out. Why is that the end of the world? Well, if there was anything in common, you would have seen it back here, right? Did 3 go into all of them? No, 3 doesn't go into 13. So there can't be a 3. There wasn't a 3 in common in the beginning. There can't be a common 3 that could come out later. So it's never going to be the case that you have anything in common in the same parentheses. So the 3 can't be there, is my point. Can't be. So get rid of that. So reorder it. Put the 4 here and the 3 there. That's got to be the way the signs go. Now, I mean the way the numbers go. Now we don't know for sure though. Really, it could be 2 and 6, right? Because there's other things that multiply to be 12, or 1 and 12. There's other things other than 3 and 4. You have to try the various things. It's probably 4 and 3 though, because that's a more common pair. Let's multiply it out and see what happens. I'm just going to check it now. No signs yet. Just multiply. Boom, boom. What's that? 3x squared, 9x, boom, boom, 4x, and 12. I just did first to both, second to both. Now, how can they make a negative 13? Oh, if they're both negative. And plus 12, yeah, 2 negatives multiply to be plus 12. That's right. Check. So now I have it right. That's the correct factoring. I'll say, or you could do the negative b plus or minus the square root of b squared minus 4ac all over 2a, like we did a minute ago when we found the x-intercepts. So anyway, let's keep going. So now we have this and this equal to 0. So that means each part equals 0 separately, doesn't it? Why? Because if two things are multiplying to equal 0, what does that mean about them? What if I told you, hey, I'm thinking of two numbers. I've got a number times a number, and it's equaling 0. What does that mean? How can you multiply two things and get 0? Well, one of them's got to be 0. Either the first number could be 0, or the second number could be 0, right? If these two things here are multiplying to equal 0, then either the first one could be 0 or the second one could be 0. So that's why I set the first one to 0 and the second one 0. If either one of those is 0, they multiply to equal 0. Okay, so solve it. So jump the 4 over. 3x is 4, divide by 3. Move the 3 over, x is 3. So we got our two answers, 4/3 and 3. Those are the vertical asymptotes. So x is 4/3 and 3. So 4/3 and 3. That's the two answers they got there. Again, you could, if you don't like that, you could just have done the quadratic formula, would have gotten those same two answers instead of factoring. It's your option. When you have an x squared equation, you can either do the quadratic formula, or you can factor with the two parentheses and then set each one equal to 0 and solve. Either way. Last question, part 4. Find the horizontal asymptotes. So how do we find the horizontal asymptotes? Let's bring that down for part 4. And we put in the same thing here. There we go. All right. So let's do it. Let me move this here. All right. So, oops, kind of jumping around on me here. Whoops, because I'm not in the pen mode. There we go. Horizontal asymptotes. How do we find the horizontal asymptotes? Well, the horizontal asymptote on a graph is a horizontal line that the graph approaches, one side and the other side, flattens out. As you go towards x, on the x-axis, let me back that up, on the x-axis, as you head towards infinity, or the other way, negative infinity, the graph levels out. So basically, you let x go to infinity. How do you let x go to infinity? Well, I would suggest just plug in x equals 100. So I'll just take this formula right here, this function, this is y equals, and I'm going to plug in 100. 100 squared minus 4 times 100 minus 4 over 3 times 100 squared minus 13 times 100 plus 12. Okay, so I'm basically going to infinity. That's, 100 is, headed towards infinity. So now let's work this out to the best of our ability here. So this will be 3 times 100. So 100 squared is 100. It adds 2 zeros. So it's 300, add 2 zeros. 30,000 minus 400 minus 4 over, again, this is 30,000 minus 1,300 plus 12. Well, do you see that really this and this and this and this are chump change? They're super small, super small. They don't really matter. You might think, well, 1,300 matters. Well, it's because I only plugged in 100. Remember, we're going to infinity, really. So 100 is just the beginning. I'm going to plug in 1,000, 10,000, a million, a billion, a trillion. It's going to get gigantic. And do you see that all that's going to matter is this most powerful term on the top and the most powerful term on the bottom. When you're plugging in really big numbers headed towards infinity, see how 30,000, those are so much bigger than 400 or just 4, even way bigger than 1,300 or 12. You see, because x squared, the x squared terms are the most powerful. So if you're headed off to infinity, they're all that matters. If you're all the terms matter in general, but if you're headed to infinity or negative infinity, plugging in gigantic numbers, a million, a billion, a trillion, and squaring a million is so much bigger than just 4 times a million, right? Squaring a million means a million millions, a million times a million. That's so much bigger than just 4 million or 13 million. So all that's going to matter is the most powerful term in the top and the bottom. This is going to basically equal 1. Do you see that? Let me back up a step. It's because it's basically 30,000 over 30,000, which is 1. These other parts are so small that the further you go to the right, bigger than 100, 10,000, a million, a billion, a trillion, they're going to just so much more and more not matter, and it's just going to be 1. It's really just going to be 3x squared over 3x squared. That's why you're getting 1. All that matters is these terms when you head towards infinity. So the horizontal asymptote is y equals 1. What that means is up at 1, so here's like 2, here's 1, here's 0, negative 1. This means this graph, as you go off to the right forever, is going to level off at a height of 1. It'll do it the other side too. The graph is going to level off at a height of 1. That's the horizontal asymptote, y equals 1. And there we go for finding the horizontal asymptote.